previous modules, I was talking about SP and sp2 hybridization. In this module, I will talk about sp3 hybridization. In the sp2 hybridization, you have seen that you get 3 hybrid orbitals, which is present in the xy plane because the contributing p orbitals were px and py. And I said you can take any 2 p orbitals, py, pz, px, pz. The only difference will be that instead of xy plane, the molecular plane will change. It will be xz or yz, depending upon which combinations of p orbitals you have taken. What we have done is that we found the coefficients of each of these hybrid lobes, psi1, psi2 and psi3, and all the 9 coefficients we found. The only thing what we did is that we fixed one of the lobe along the x-axis and then we found the coefficients. It was easier to fix along one axis, and making C1 is equal to 0, we were able to find out all the 9 coefficients for the orbitals. Thereafter, I said you that the square of the coefficients gives you contribution. So if you square it, then we found that in each of the lobe there is a 1/3 contribution from s orbital and 2/3 contribution from the p orbital. So we call it sp2 hybridization. We also find using the spherical harmonics the angle between the hybrid lobes, and we proved what we did. We fixed one of the since we have fixed one of the lobe along the x-axis, so we tried to find out the maxima of the psi2 or the second wave functions in this xy plane. And what we found is that the maxima lies at 120-degree angle. Okay. And then I said you that if you put these 120-degree angle value and you find for the phi angle, because theta is 90-degree in the xy plane, this is your xy plane and this is your z axis. So theta is 90-degree in this plane always, and sin theta becomes equal to 1. Now if you put the value of 120-degree phi value, then what we got is tan phi is equal to √3 minus √3, I think, and then we found the phi angle equal to 120-degree angle. If you put the value of 120-degree angle and you find the numerical value of the psi1 and psi2 and psi3, all comes out to be 1.99. So this result tells you that all the hybrid lobe from sp2 hybridizations are equivalent. So what we did, we found the wave functions of the sp2 hybrid lobe by finding out the coefficients. We found that with all these hybrid lobes are equivalent, and we also found quantitatively that these hybrid lobes are in the xy plane at an angle of 120-degree angle. Okay. So this was the previous module which we talked about. I am going to extend the same concept. The similar concept is this to the new hybridization, sp2 hybridization. Okay. In sp3 hybridization. In sp3 hybridization, there is 1 s orbital and 3 p orbitals which combine together to give you 4 hybrid orbitals. And all of you know that the structure is tetrahedral structure, and the most common molecule is methane molecule. Okay. So we talked about methane molecule. It is methane molecule. The 3-dimensional structure of methane molecules generated by this is your carbon, and these are hydrogen atoms. Okay. So methane molecule is this one. It's generated by a software that you can learn later on, visualization software you can generate. But the easiest way to draw a tetrahedral structure is that draw a cube, and then on the alternate corner you put your one of the atoms, 1, 2, 3 and 4. And the central atom, put the central atom at the center of the cube and join them. This will give you a tetrahedral structure. Tetrahedral structure is three orbitals in a pyramidal fashion, and the 4th one on the top of the pyramid, and each is making with each other. Tetrahedral structure makes an angle of 109 degrees 28 minutes, that you know, 109.5 degree is the angle. So this structure is known to you, the angle is known to you, the wave function we will try to find out for this sp3 hybridization, and again the coefficients also you will have to find out. What we can do, what we can do is that if we suppose that in all the hybrid lobes the contribution of p orbital is equivalent, This is assumption. If we assume, then what you can write? We can write the wave function. Suppose you have 4 hybrid lobes. So 4 hybrid lobes and in each of these hybrid lobes there is a contribution from s orbital. So if you say it is a psi s for all these, so a psi s, a psi s, a psi s and a psi s for psi 1, for psi 2, for psi 3 and psi 4. Okay. So what does it mean? If you count the contribution will be 4 a square and this will be equal to 1. Okay. And so a will be equal to 1 by 2. So the first coefficient you can write 1 by 2, 1 by 2, 1 by 2, 1 by 2. Okay. Then this is 1 by 2 is the contribution of a, and coefficients of a, contribution is a square. Okay. So it is contribution will be what? A square will be 1 by 4. What is the remaining part? Remaining part is 3 divided by 4. And how many p orbitals are there? 3 orbitals. Psi p 2px, psi 2py, psi 2pz. Here I have written psi 2px, psi 2py, psi 2pz. So if you suppose that equally they are contributing, then this we can split as 1 by 4 plus 1 by 4 plus 1 by 4 is the contribution of px, is the contribution of py, is the contribution of pz. And if this is the contribution 1 by 4, it means the coefficients, if you write for psi px as b1 psi px plus c1 psi py plus d1 psi pz, then what does it mean? For px, I can say b1 square and this will be equal to 1 by 4. So b1 will be what? b1 will be 1 by 2. Same will be case with the c1 also, and same will be case with the d1 also. Okay. So all four coefficients will be 1 by 2, 1 by 2, 1 by 2. Provided we suppose it makes p orbital makes equal contribution. This is a rider. Then only you can write this one. Okay. If you find out for psi h2, then what you can write? You can write again the contribution for a remains same, contribution of psi s remains same 1 by 4. So here also you can write 3 by 4, 1 by 4, 1 by 4, 1 by 4 is the contribution. So what does it mean? It means b1 square is equal to 1 by 4. So b1 is plus minus 1 by 2. Same way, if you write b2 psi px, c2 psi py plus d2 psi pz, then b2 also will be plus minus and plus minus. Okay. So again you can write plus plus plus. I have not written plus plus plus. Why it is so? That the hybrid lobes which you obtain, that also should be orthogonal to each other. So if you write a relationship psi h1 sp3 and psi h2 sp3, then this integral d tau should be equal to 0. Sorry for the bad handwriting, but I can't help it. Okay, I will try. Psi h2, okay, d tau. So this function has to be equal to 0, and for making it equal to 0, what is this for orthogonality condition? What will happen if you put all function equal to plus 1, then this will multiply with this one and it will make 1 by 4. This will make with 1 by 4, 1 by 4. This will make 1 by 4, 1 by 4. This will make 1 by 4, 1 by 4. Multiply. So 1 by 4 plus 1 by 4 plus 1 by 4 plus 5 will be equal to 1. So you have to give two negative sign, then only 2 of the 1 by 4 will go and 2 will remain with the 2 of the positive 1 by 4, and then it will become 0. So for writing the psi h2, I have given a negative sign in place of B2 and C2. The condition will remain same for the third hybrid orbital also. So what you can do here, you can shift the number, the negative charge at the end. So I have shifted, you can do it anywhere, but 2 of the contribution will be negative, 2 coefficients will be negative, 1 coefficient will be positive for psi px. In the next 3, first one I have written as plus, since first one I have written as plus plus plus, so in all the next 3 wave functions, you will have to give 2 negative signs to the p orbitals and 1 positive sign to the p orbital. Of course, S is positive. So then, what does it do? It fulfills the orthogonality condition of the hybrid lobe wave functions. So one way of doing this, finding out the coefficient is this. But here we have supposed that p orbitals makes equal contribution to each of the lobe. This may not. If we don't suppose this, then how to find out? There are ways to find out. And I will give you other functions also. Both approaches given in the book, so both approach I will give you. Okay. So this is what I have written. You see, 1 by 2. Okay. So what is this? 3c1 square is equal to 3 by 4. So c1 square is 1 by 4. I have done all this. I have written it for your convenience here. So c1 becomes plus minus 1 by 2. And if psi h1 is this one, then psi h2 cannot be this one. Okay, it cannot be this one, because of course the coefficient value I have not written. So this is your function. If you write this one, then the coefficient's value will be this one, negative sign. Okay, 2 negative sign you will have to give, because of this condition, orthogonality condition. This is orthogonality condition, eta is equal to 0. And so it will be 1 by 4 plus c3 square by 2 plus c4 square by 2 plus c5 square by 2 is equal to 0. Okay, and then it means c3 is equal to c3 square plus c4 square plus c5 square is equal to 3 by 4. So c3 is equal to c4 is equal to c5 is equal to plus minus 1 by 2. Okay, and this will become 0 only when you take 2 of these equal to this one. 2 of this is equal to 1 by 4 plus 1 by 2 plus 1 by 2 plus 1 by 2 is equal to 0. And if you have c3 square, c4 square, c5 square will be contribution is 3 by 4. So it is, for each of these it will be 1 by 4, 1 by 4, 1 by 4, and if you remove their square, then it will be plus minus 1 by 2, plus minus 1 by 2, and then this function we can write. But remember that we have started talking about the lobes of the sp3 hybridization by saying that there is equal contribution from the p orbital. Okay. If we don't suppose this, then how can we find out? We can find out then also the different coefficients. So the normal way by which we were talking about was this one, that you write the 4 coefficients. Psi1 is equal to a1 psi s plus b1 psi px plus c1 psi py plus d1 psi pz. And then for psi2 psi 2 psi s plus b2 psi px plus c2 psi py plus d2 psi pz. For psi3 you can write a3 psi s plus b3 psi px plus c3 psi py plus d3 psi pz. And for psi4 you can write a4 psi s plus b4 psi px plus c4 psi py plus d4 psi. Now you have 16 different coefficients which you have to find out. Okay, a1, a2, a3, b1, b2, a1, a2, a3, a4, b1, b2, b3, b4, and so on. All 16 coefficients. Okay, and for finding out this, again, the first thing which we say is that s orbital is contributing equally. So the contribution is given by a square of the coefficients. It means a1 square is equal to a2 square is equal to a3 square is equal to a4 square. And so equal contribution to 4 means it is 1 by 4. One s orbital is distributed in 4 hybrid lobes. So a1, a2, a3, 4 and a4 are 1 by 2. That is very easy to see. So 4 coefficients you have found. Now what you say is that, remember, if in sp2 hybridization I said you that one of the lobe is along the x-axis. Here what we say is that the hybrid lobe, one of the hybrid lobes, say psi 1 is fixed on x-axis. Okay, here also I am saying the same thing. So that the now if it is on the x-axis, then what will happen? Py and Pz will not contribute, and so C1 will become 0 and D1 will become 0. So two more coefficients you know. See the difference between the two approach of finding out the wave function for sp3 hybridization. And then normalization of psi 1 will give you how much? The C1 is 0 and D1 is 0, so what you have? Your psi 1 is now reduces to A1 psi s plus B1 psi px, I think. Okay. Px. Py and Pz contribution is 0. So if you write the normalization condition for this, since we have seen, I have done it many times, so I will not do. It's A1 square plus B1 square is equal to 1. And A1 value is known to you. Okay, it's 1 by 2. So B1 square will be 1 minus A1 square, and 1 minus A1 square is 1 by 4. So it's equal to 3 by 4, and B1 will be root under 3 divided by 4, so root 3 by 2. So B1 value we found. Okay. Then what we say is that one of the lobe is along the x-axis, that remember. And then you use the orthogonality condition of psi 1, psi 2, psi 1, psi 3 and psi 1, psi 4. How do we get this relation? We did it in sp2 hybridization. So again I will not do that details. You can see that if you write the two functions psi 1 and psi 2 and you write the orthogonality condition, you get this equation: a1 a2 plus b1 b2 is equal to 0, a1 a3 plus b1 b3 is equal to 0, a1 a4 plus b1 b4 is equal to 0. And if you look at the first equation, then b2 you can write as minus a1 a2 divided by b1. Okay. If you write the second equation, then you can write b3 is equal to a1 a3 divided by b1. And if you write the fourth equation, then you can write b4 is equal to a1 a4 divided by b1. So, and a1, a2, a3, a4 all are equal. So, all will be b2, b3, b4 will be equal. So, calculating only one of this, a1 multiplied by a2 will be 1 by 4, and b1 we have determined as root 3 by 2. So, it comes out to be minus 1 over 2 root 3. Okay, this we found. Now, we make a second assumption, because we are going to the 3 dimension. So, we make a second assumption and we say that the second hybrid orbital lies in the xz plane. Okay. So, initially I said you it's x-axis along one of the lobe is along the x-axis, and then you have a z-axis here. So, this is your xz plane, and we fix another orbital in the xz plane. So, py contribution will be nil, and then C2 will be equal to 0. Okay. So, C2 is equal to 0. Then if you C2 is equal to 0, then for psi 2 you can write A2 square plus B2 square plus D2 square, because normalization condition is this one, and C2 you have taken 0 because you have fixed. So, the first assumption was that psi 1 is on x axis, and second assumption is that psi 2 is in xz plane. Okay. And if it is in xz plane, then C2 becomes equal to 0. So, you have A1, A2, B2 and D2, and that will be a square. A2 square plus B2 square plus D2 square will be 1 because of normalization condition. See, all through hybridization, we are simply using the concept of orthogonality and normalization, nothing else, no difficult concept. It's very simple concept. In the initial lectures, I talked about the normalization orthogonality, and I am using here the same concept of normalization orthogonality in order to find out the coefficients of hybrid orbital lobes. Okay. So, d2 square I can write as 1 minus a2 square plus b2 square, and this value you do have. So, finally, d2 comes out to be root under 2 by 3. Okay. So, many coefficients we found, and now next is the orthogonality condition of psi 2 psi 3 and psi 2 psi 4. Now, you see in psi 2 you have a2, b2 and d2 only. So, you have your psi 2 becomes equal to a2 psi s plus b2 psi px plus d2 psi, I think, pz. Py contribution is nil. Okay. xz, okay, d2 is equal to psi pz. So you have these three in psi 2, and in psi 3 you have 4, a3 psi s plus b3 psi px plus c3 psi py plus d3 psi pz. And if you write the orthogonality condition, then a1, a2, a3, b2, b3 and d2, d3 will remain. It will not be c3, c2 because c2 is already 0. Okay. So you have this condition for the psi 2, psi 3 normalization, and for psi 2, psi 4 normalization, similarly, you can write a2, a4 plus b2, b4 plus d2, d4 is equal to 0. And what does that mean? If you find the value of d3, then this comes out to be minus 1 by root 6, and this is the same as d4 also. So d3 and d4 are equal, and this is equal to minus 1 by root 6. Okay. I think we have done enough of this, and now normalization condition of psi 3 if you write, then you can find out. So you have a3 value, you have b3 value, you have d3 value. The only value which you don't know is c3 value. So c3 value you can find, and it is 1 by root 2. Similar calculation of normalization condition of psi 4. So I have not written it. You can write it a4 square plus b4 square plus c4 square plus d4 square is equal to 1. And so c4 also comes out to be minus 1 by root 2. See, both c3 and c4 is actually c3 and c4 is equal to plus minus 1 by root 2. In one case I have taken the positive root, in another case I have taken the negative root, knowingly, because then only the hybrid lobes wave function will get will be different, otherwise it will be hybrid lobe wave function will be same. Okay. So we have found the coefficients, and these are the coefficients which we have found. a1, a2, a3, a4 all is same 1 by 2, b1 is root 3 by 2, then b2, b3, b4 is minus 1 by 2 root 3, c1 is 0, c2 is 0, c3 is 1 by root 2, c4 is minus 1 by root 2, d1 is 0, d2 is root 2 by 3, d3, d4 is equal to minus 1 by root 1 by root 6. So all 16 coefficients we found, but it is different from what we did in the beginning. In the beginning, c1, c2 was not 0, it was 1 by 2, d1 was not 0, it was 1 by 2. Okay. But the condition where there it was that all p orbitals are contributing equally to the hybrid lobes. If you omit that condition, equal contribution, because in this case, if you have put c1 is equal to 0, then what does it mean? It means where do you have c1? C1 you have for py orbital in the psi1 function. So what you want to say that in the first wave for hybrid lobe, that is represented by psi1, py does not contribute. Okay. Then you have c2 is equal to 0. So in the second function also, py does not contribute. So the two conditions are different. In the first condition, you say that all p orbitals are contributing equally to the 4 hybrid lobes, and then you found that for every coefficient, for all 16 coefficients, you can write 1 by 2, 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 except the positive and negative sign is different, and why it is different we discussed. Okay. But when you suppose that no, this condition is not there, that all p orbitals contributes equally, then you get a different coefficient and a different wave functions. So these are the different coefficients which you obtain, and now you can write the function in terms of the coefficients which we have determined. You see, the psi1 has the only contribution of psi s and psi px, no contribution from psi py and psi pz. Psi 2 has contribution from psi s, psi px and psi pz, but psi py does not contribute. And in psi 3 and psi 4, there is contribution from each of these, psi px, psi py and psi pz, but that contribution is not equal. Okay. If I say what is the contribution of psi pz in psi 3, it will be 1 by 6, because the coefficient is minus 1 by root 6, so if you square it, it is 1 by 6. If I ask what is the contribution of py in psi 3, that is 1 by root 2, so it will be 1 by 2. Okay. So this way you see that different orbitals are hybrid lobes have different contributions of atomic orbitals in this case. In the previous case, it was an equivalent contribution from the everyone. Okay. If you go for angular functions, and you write the spherical harmonics in the same fashion as we did earlier, the relative value of S orbital is 1, the relative value of Pz orbital is root 3 cos theta, the relative value of Px orbital is root 3 sin theta cos phi, and the relative value of Py orbital is sin theta sin phi. If I use this, then in terms of these functions, these spherical harmonics I have written psi 1, psi 2, psi 3 and psi 4. So it's nothing but the value I have put here for the psi px, psi py, psi pz, and you get these equations. Okay, that's very easy for you to see. Now we say that since we assume psi 1 to be along x-axis, and along the x-axis phi is equal to 0 degree and theta is equal to 90 degree. Okay, so you know the value of phi also along the x-axis, because and the value of theta is 90 degree. So what is the value of psi 1? Psi 1 will be 1 by 2. Psi 1 is what? 1 by 2 root 3 by 2 root 3 sin theta cos phi. So it will be 1 by 2 plus root 3 by 2 into root theta, and this will be equal to 1 by 2 plus 3 by 2, and it comes out to be 2. Okay, obviously it will be 2. Another assumption we made is that psi 2 lies in the xz plane. Of course, we made these assumptions, and in xz plane phi is equal to 0, because phi is the angle in the xy plane, okay, or 180 degree. So taking cos phi is equal to minus 1 for phi is equal to 180, what do you get? Phi 2 is equal to 1 by 2 minus x. See, if I say xz plane, then this is your xz plane. Okay, angle is here in the xy plane. Along the x-axis you have either 0 axis or 180 degree angle, phi angle. So in the xz plane you have 0 also, phi is equal to 0 also, and phi is equal to 180 degree also. So I have taken phi is equal to 180, and if you calculate this one, if you do these calculations, what do you find? You find this as 1 by 2 minus 1 by 2 root 3, root 3 root 3 will plus 2 root 2 by 3 root 3 cos theta. So it is 1 by 2 plus 1 by 2 sin theta, root 3 and root 3 will go, sin theta plus root 2 cos theta. Okay, only phi angle I have taken, so theta will remain. Okay, so the cos phi became minus 1, so minus sign will be multiplied by this minus sign, it became positive. Okay, and then here you have cos theta only, so cos theta remains. So 1 by 2 plus 1 by 2 sin theta plus root 2 by cos theta you have. Now if you want to find out the maxima of the psi 2 function, then what will you do? You will differentiate it, psi 2 function, with respect to theta, and you differentiate with respect to theta this function, then you get tan theta is equal to 0.354 value, and this theta comes out to be 19 degree 28 minute. Remember that your first function is along the x-axis. Okay, so what we have found is that this was your x-axis, this is your z-axis. Okay, and then you have theta is equal to 90 degree, means 19.28 degree, means if you have the 90 degree plus 19 degree 28 minute will make it 109 degree 28 minute angle. So your first angle was this one along the theta axis. This was your first lobe. Okay, and this is your 90 degree. From this 90 degree you will go to 19 degree also, and the second lobe will be at this point. This angle is 19 degree 28 minute. So this is your psi 1, this is your psi 2, and the total angle is in between the angle is 109 degree 28 minute. So we found the coefficients in the two different fashion, and we found the actual value of the angle also. What you can do, you can find out the actual value of psi 1, psi 2 and psi 3 also by putting these values of 109 degree 28 minutes. So if you put this value of theta 19 degree 28 minutes in your psi1 function, in your psi2 function, then you will get a value equal to 2 for psi2 also. And that tells you that all the hybrid lobe which you obtain from sp3 hybridization are equivalent. Okay. So we started talking about valence bond theory by from the H2 molecule, a diatomic molecule, and I said you that the concept of H11, S11, resonance integral, overlap integral, all those we talked about. And after talking about the diatomic molecule, we started talking about combination of atomic orbitals to give you hybridization. And we talked about sp hybridization, sp2 hybridization, sp3 hybridization. I think this is enough discussion for valence bond theory for your course, and we will continue with other topics in the next module. Thank you.